Before we dive into software monitoring, let's take a moment to understand why it's essential and what use cases does it serve. Analyzing software monitoring data can seem like a complex investigation, and that's because it truly is. The basic question to be answered is there a problem? What is the nature of the problem, and how can the problem be fixed? Imagine a software engineer as a medical doctor or a detective. Just as a doctor diagnoses a patient by examining symptoms or a detective solves a mystery by following clues, an engineer uncovers the root causes of software failure by analyzing software monitoring data. This investigative approach allows engineers to dig deep into the system, finding the root causes of issues, just as Sherlock Holmes would in a crime scene, or Dr. House would when diagnosing a complicated medical case. When software engineers analyze monitoring data, they're investigating the behavior of the software. Software behavior, in this sense, refers to everything that happens during software runtime, be that in software testing or software operations. It's about understanding, is everything working correctly, or figuring out what went wrong. Through this process, engineers use logs, metrics, traces, and other monitoring data as their clues. Our first use case for monitoring data is root cause analysis. This process can be referred to as event-initiated analytics. When something goes wrong, our goal is to identify the root cause. How do we do this? By analyzing monitoring data, we can trace back through the events leading up to the failure to understand what went wrong. For small or simple software systems, this task is usually straightforward. A limited number of components and interactions means fewer potential points of failure. However, as software becomes larger and more complex, this task grows more challenging. With increased size and complexity, there are more interactions and potential sources of failure to consider. Understandably, root cause analysis is more often done for software that has higher required reliability. For example, aircraft flight software has higher reliability need than mobile games. Root cause analysis can prevent similar failures in the future by understanding exactly what went wrong and addressing the underlying issues. Now, let's explore use case 2, monitoring. Monitoring use case involves what we call continuous analytics. Rather than waiting for a failure to analyze data, we continuously analyze logs, metrics as part of regular operations. This ongoing process is especially crucial in modern, service-oriented software environments that should be continuously available. One other area for continuous monitoring is in continuous integration or CI. In CI, monitoring helps automate the build and testing processes, ensuring that issues are detected early in the development lifecycle. By observing log data continuously, we can detect deviations from normal behavior. During testing, these deviations can be treated similarly to failing test cases, helping us catch potential issues before they reach production. In live operations, deviations can serve as early warning signs, prompting automated actions to prevent more severe problems. For example, if certain services start showing signs of instability, we could automatically reboot them to avoid a situation where the entire system becomes unresponsive. Through continuous monitoring, we achieve a proactive stance and ensure reliability and performance while minimizing downtime. Our third use case focuses on security. In security, monitoring data plays a crucial role in maintaining the safety of software system. Firstly, monitoring through intrusion detection logs helps identify suspicious activities. These logs capture unauthorized access attempts, login failures, and unusual usage patterns, serving as a warning system against potential threats. Secondly, in an event-driven security incident investigation, monitoring data becomes essential for tracing security breaches. This data allows us to track the source, timeline, and impact of an incident, aiding in both root cause analysis and swift mitigation efforts. Now, moving to our final use case, regulations and laws. To comply with numerous regulations, monitoring data collection often becomes the only practical solution. To achieve audit trail for accountability, logs provide a record of user actions such as data modifications, access to sensitive information, and system changes. This audit trail is important for tracing responsibility and ensuring compliance with regulations. Lastly, it's worth noting that log collection isn't optional in some cases. If log collection is not forced by the law, it might be heavily implied. Various laws and standards demand log or monitoring data collection to maintain accountability and transparency. The regulatory significance of log data is evident in news articles such as those reporting instances where individuals are caught engaging in unauthorized viewing of sensitive information.